The 68000 ISA provides an extensive set of instructions, most of which can operate on any of the three possible sizes of operands. The instruction set is summarized in Appendix C. All addressing modes can be used in a uniform way with most instructions. Instruction sets that exhibit this feature are said to be orthogonal. By the term orthogonal, we mean that in the sense that the instruction type and addressing mode vary differently. The 68000 has both one operand and two operand instructions. A two operand instruction is written as OP SRC DST, where the operation OP is performed using the source and destination operands. The result is placed in the destination location. An example is given in Figure 3.21, which shows the instruction add 9 to destination 3. This will perform the addition instruction shown, which will result in adding the value of 9 to the contents of register D3 and storing the result back in D3. Figure 3.21a depicts the general format of the add instruction. Either the source operand or the destination operand must be in a data register. The second operand may be in a register or a memory location. The allowable combinations are given in Table C4. Since at least one of the two operands is always in one of the 8 data registers, a 3-bit field suffices to identify it. The other operand is specified according to Table C1. In our example, the destination register D3 is represented by the binary pattern 0, 1, 1 in bits 9 through 11, and the immediate source operand is identified with the pattern 1, 1, 1, 1, 0, 0 in bits 0 through 5. The desired operand size is indicated in the 2-bit size field. In our example, the size of the operand is not stated explicitly in the assembly language statement, in which case the assembler assumes the default value of a 16-bit word. According to Table C3, word size operands are denoted by the pattern 0, 1. From the discussion above, it follows that the OP code word for our add instruction is 1101, 0110, 0111, 1100, which is represented by the hex number DC7C, as indicated in Figure 3.21b. The immediate source operand 9 is given in the word following the OP code word as shown in Figure 3.21c. Before fetching the instruction, the program counter points to the OP code word at address I. As each word is fetched from the memory, the contents of the PC are incremented by 2. Thus, when execution of the instruction is completed, the PC points to the OP code word of the next instruction at address I plus 4. A similar instruction using the same format is the subtract instruction, sub, which performs the operation shown. As Table C4 shows, the add and sub instructions allow considerable flexibility in specifying one of the two operands. However, the second operand must be in a data register. Most other two-operand instructions have the same type of restriction. The only instruction in which both the source and destination operands may be specified in terms of most of the addressing modes is the move instruction, move, which performs the action shown. Let us now consider a simple routine for the task where the sum of A and B are moved to C. The required task can be performed as follows. These instructions may be stored in the memory of a 68000 computer, as shown in Figure 3.22. The figure shows hexadecimal values for the addresses and operands. The operands are assumed to be 16 bits long, and their addresses are specified in the absolute mode. Note that the long version of the absolute mode is needed because the desired addresses cannot be represented in 16 bits. The high-order 16 bits of a 32-bit address are placed on the lower address and the low-order 16 bits in the higher address word, according to the convention shown in Figure 3.19. The discussion of assembly languages in section 2.6 applies generally to the 68,000 assembly language. Some minor differences and additions are explained here. Because 68,000 instructions can deal with three different sizes of operands, the assembler instructions must indicate the desired size. This is done by appending the size indicator to the operation mnemonic. The size indicator is L for long word, W for word, and B for byte. Thus, if an add instruction is to operate on long word operands, its operation mnemonic is written as add L. When no size indication is given, the operand size is taken to be one word. This means that the instruction add W20 to D1 and add 20 to D1 are identical. Numbers in a source program are assumed to be in decimal representation unless marked with a prefix $sign for hexadecimal or percent sign for binary. Alphanumeric characters placed between single quotes are replaced by the assembler with their ASCII codes. Several characters may be specified in a string between quotes. All of the assembler's directives discussed in section 2.6 can be used with only slight differences in notation. The starting address of a block of instructions or data is specified with the org directives. The EQU directives equates names with numerical values. Data constants are inserted into an object program using the DC directives. The size indicator is appended to specify the size of the data items, and several items may be defined in one directives.